Welcome to Learning with Lai. In my video about speed, I talked about a race between two kids whereby it resulted to the average speed of each of the racers. But let's take an instance whereby a person running on a track covers equal distances in equal times. Let's imagine we have a track like this and someone covers this distance in 5 minutes, and the distance from there to there, from this point to this point, is 10 kilometers, and the person also covers it again 5 minutes, 10 kilometers, 5 minutes, 10 kilometers, 5 minutes, 10 kilometers, 5 minutes, and it goes on like that till the end of this track. So what the illustration above shows that the person running on this track has a uniform speed. So all what is happening here, 5 minutes in 10 kilometers, you can see it equal distances in equal time, so they are both equal. So this is what we call uniform speed. Let's now discuss about uniform velocity. Uniform velocity occurs when the rate of change of distance moved in a specified direction or displacement of an object or body is constant. By illustrating that, we're going to have a straight path. Don't mind my straight path, it's not really straight, but for illustration purpose, this is a straight path because this is a distance in a specified direction or in a specific direction. So if you have a train moving on this straight path, the same idea, if it's going to cover 5 minutes from this point, let us now imagine in 20 kilometers the distance covered, the train is moving also again, it covers another distance which moves 5 minutes, 20 kilometers, 5 minutes, this point 20 kilometers, and the train keeps on moving like that to the end of this particular path or track. So we can see that we have equal displacements in equal times. And this is the same thing as saying that the rate of change of distance moved in a specified direction is constant. So we can see it, the rate of change of distance, because when we look at the change between this point and this point, is still going to give us 20 kilometers and it is covered in equal times. So that is uniform velocity. Let us now look at uniform acceleration. Uniform acceleration occurs when the rate of change of velocity of a body or object is equal with time. So when we have the rate of change of velocity of a body or object is equal with time. If we look at a simple illustration to explain this, let's take for instance we have a skateboarder sliding down a ramp. So we have the skateboarder here. So we have the skateboarder and we have a ramp moving like this. So this skateboarder on this ramp would be found to be increasing his velocity, because this is a displacement covered, because this will be in a specified direction going either, if we look at our cardinal point, we have the north, the east, the south and west, and this part will be the southeast. So this is in the southeast direction, the skateboarder sliding down this ramp. So we have a particular direction until when the skateboarder gets to the bottom of this ramp, then you have a new change in the direction and you'll be moving towards the northeast direction if you look at it in terms of cardinal point. So this skateboarder sliding down this ramp, if he moves from this point, from the initial position where he is, and he slides down to this point, if the change in his velocity from zero, because this is the starting point, this will be zero, and he gets to this point, his velocity has increased to 20 meters per second, and the time he used to cover that was 5 seconds. He moves to another point, also the change in the velocity from the distance here, that means this point here should be 40. He has gotten to 40 meters per second, but when we subtract this to notice the change, it will still give us 20, and he also covered that in 5 seconds. The time taken to get to that new point was also 5 seconds. It keeps on moving like that. This place will be 60 meter per second, and this will be also in 5 seconds, and keeps on increasing down this ramp, 80 meter per second in 5 seconds till it gets to the bottom of this ramp. So all what is happening here, you can see that the rate of change of velocity of a body of this skateboarder, this is the body now, is equal with time. So we can see it, we have equal time and equal change in velocity. So this is what we call uniform acceleration, because the change of velocity, because when you have the formula of acceleration is change in velocity over the time taken, and we can see that the rate of change of velocity is equal. So this is uniform uniform acceleration. Also, raindrop or water drop from a particular height moves with a uniform acceleration, and we can look at it whereby this is the particular height of the raindrop from this height, and we have the water somewhere here, the drop. And if we look at this distance from this point here, this is the initial position of the raindrop, and if it gets to this point, the velocity change is going to be 9.8 meter per second under 1 second. 1 second. And it keeps on moving like that. To get to another point would also be 9.8 meter per second in 1 second, because the time taken to move from this new point, when the raindrop gets to this point, to get to this other new point would also be under 1 second, and the change in the velocity will still remain to be 9.8 meter per second. Unlike this one, we have to subtract to get the change in the velocity, and if we still subtract to get the change, it will give us 20 meter per second. Also, looking at other points on the skate ramp, we still have 20 meter per second. This is the initial point of the skateboard. This will also be 20 meter per second. So this is the same case for a water drop or raindrop falling from a particular height. So we can see that uniform acceleration occurs in a specific direction, because if you can remember that acceleration is a vector quantity, and it always have a direction.